Okay, today we're going to finish off the rest of section 9.1. We'd gotten started on this one Friday, and the main topic in this section is the Pythagorean theorem. So mainly for anybody who wasn't here on Friday, just a quick review. The idea with Pythagorean theorem is anytime you have a right triangle, a triangle with a 90-degree angle, then we'll always know that the leg squared plus the other leg squared is equal to the hypotenuse squared. Where, if you don't remember, the side directly across from the 90-degree angle of a right triangle is called the hypotenuse, and the two sides that make up the 90-degree angle are each called a leg. All right? Now, normally we don't write out leg squared plus leg squared equals hypotenuse squared. We usually abbreviate that a little bit by using letters. So many times we'll use A and B for the two legs, and we'll use the letter C for the hypotenuse. So many times people will remember the Pythagorean theorem as A squared plus B squared is equal to C squared. But what's important to remember is that the hypotenuse is the one value all by itself. The legs are the two that are being added together, but the hypotenuse is the one by itself. Okay, so just one review problem from Friday, just one quick one. If we were to have a right triangle and we knew the hypotenuse was 24 units long, and we knew one of the legs was 10 units long, what we might be looking to do is find the other side. I'm going to choose to call M. So what's important is for you to identify the hypotenuse, and therefore, I'll just abbreviate that here. And so the other two are the legs. Okay, so the Pythagorean theorem then says leg squared plus leg squared is equal to hypotenuse squared. So in this case, that's m squared plus 10 squared equals 24 squared. We dig out our calculators. 10 squared is 100. 24 squared is 576. We move plus 100 to the other side by subtraction. And to get rid of the power of 2, we take the square root of both sides. So side M then is going to be approximately equal to the square root of 476, which is approximately 21.8. Remember, we're going to round everything to the nearest tenth. So that's just a review problem, either to get your brain back into what we were doing last week, or if you were missing on Friday, that's what we were up to, finding the missing side of a right triangle. Okay, now moving on to new stuff that we didn't get to on Friday. Using Pythagorean theorem, what we're going to then extend that to is finding the area of a triangle. Okay, and to find the area of a triangle, the formula that you learned in elementary school, probably 5th grade, I believe it was, is that the area of a triangle is equal to 1/2 times the base times the height. 1/2 times base times height, with the condition that the base and the height have to be perpendicular to each other. All right, they have to be perpendicular to each other. So if we have a right triangle and the base and the height have to be perpendicular to each other, that means the base is one of the legs and the height is the other leg, if we have a right triangle. Okay, so keep that in mind. So now I'm going to give you a few examples where I'm going to ask you to find the area of a triangle, and we'll start off with the real easy one. So here's a very easy area to find. If we have a right triangle, this side is 12 and this side is 8 centimeters. What I would ask you for is the area of that triangle. The formula again, 1/2 times base times height. But again, the base and the height have to be perpendicular to each other. And is that what we have in the picture? Are the two sides that you know perpendicular to each other? Sure, we know this side is 12, this side is 8, and you see the right angle. So the two sides that are given are the base and height. So one of these is 12 and the other one is 8. Doesn't matter which is which because we're multiplying. So then the area of the triangle is 1/2 times 12 times 8. And when we punch that out, we get 48. And then remember, area is measured in square units. So in this case, it would be square centimeters. So we started with an easy one, but we can make them a little bit harder on everybody. So my second example, this one's going to be a titch tougher. Once again, we're going to have a right triangle. This time I'm going to tell you this side is 10 inches and this side is 7 inches. And once again, I'm going to ask you for the area of that triangle. The formula once again is 1/2 times base times height. But again, the condition, the base and the height have to be perpendicular to each other. So we have to know the two sides that are perpendicular. Well, we know one of those sides is 7, but we don't know the other. We don't know the other perpendicular side. So if you want to, you could fill one of those numbers in. We could fill in 7, but we don't know what the other one is. So are we stuck? Of course not, because we have a right triangle and we know 2 out of the 3 sides. So we could use Pythagorean theorem to get the third side. Please notice that the 10 is across from the 90-degree angle, so that's the hypotenuse. Therefore, 7 is one of the legs, right? So therefore, the other leg is missing. So we could call that a variable. Temporarily, maybe I'll just call it question mark. And so Pythagorean theorem then is going to be 7 squared plus question mark squared is equal to 10 squared. Again, dig out our calculators. 7 squared is 49. 10 squared is 100. To move 49 to the other side, we'd subtract. And to get rid of the power of 2, we take the square root of both sides. So the missing side then is going to be the square root of 51. And, oops, sorry about that. There we go. And the square root of 51 is about 7.1. So our other leg is 7.1. But again, please notice where the right angle is. Whoops, I hit the wrong button there. Please notice our right angle. All right, so the two that are perpendicular are the base and the height. So one is 7 and the other is 7.1. Okay, and now we just punch out the math. 1/2 times 7 times 7.1 gets us 24.85, so we'll round to 24.9, and we're in inches this time, so square inches. All right? So again, the biggest hiccup is for folks to just use the two numbers that are given in the problem without paying attention to the fact that the base and the height have to be perpendicular to each other. So that's the condition, right? One more time, the base and the height have to be perpendicular to each other. Okay, and I've got one last example I'm going to jog through for area. So here's the last example for dealing with area. And this time we're not going to have a right triangle, but what we will have is an isosceles triangle. So let me write down the values here. This is 10 millimeters, 10 millimeters, and this side is 14 millimeters. Okay, once again, I'm going to ask you guys for the area of that triangle, and the formula once again is 1/2 times the base times the height, with the condition that the base and the height have to be perpendicular to each other. All right, and when you look at the triangle, you might think we're in a boatload of trouble because we don't have any sides perpendicular to each other. All right, so it seems like we might be stuck. But we can find a perpendicular by remembering some geometry from earlier this year. And if I draw in from the top angle, all right, from the top angle, it's called the vertex angle of an isosceles triangle, but if I draw a perpendicular from that angle to the 14 millimeter side, if I draw a perpendicular, earlier this year, we proved that if we draw that perpendicular, it actually cuts the base into two equal parts. So if let me choose a better pointer. There we go. So if the base is 14 millimeters and we draw in this perpendicular line, that cuts it into two pieces of 7. So we'd have 7 millimeters there, 7 millimeters there, right? And how does that help you? Well, by drawing in the perpendicular, we now have a 90-degree angle. So there's the 90-degree angle, right? And so this line that we drew in, oops, let me get rid of that. There we go. The line that we drew in is actually the height of the triangle, right? So the base is now going to be the bottom of our triangle, so that's going to be the 14. And what we have to then do is find the height by Pythagorean theorem. So we consider one of the triangles, either the one over to the right or the one over to the left, it doesn't matter. We just consider one of those triangles, and you might now notice that we know 2 out of the 3 sides. We know the side directly across from the right angle is 10, and so therefore that's the hypotenuse, and then the 7 has to be a leg, so therefore the h is the other leg. And we can once again use Pythagorean theorem. Leg squared plus leg squared is equal to hypotenuse squared. And I picked the numbers that were the same so we could do this part quickly. What I mean is same as the previous problem. 7 squared is 49, 10 squared is 100. Move 49 to the other side by subtraction and take the square root. So h, just as we had in the previous problem, is going to be 7.1. So our height for the triangle is 7.1. And therefore the area, just dig out your calculator, 1/2 times 14 times 7.1. And what we get as a result is an area of 49.7, and in this case, whoops, gosh darn it, 49.7 square millimeters. Okay? Alrighty. And the last thing we need to talk about for this section is the following, that whenever we find a group of numbers that fit the Pythagorean theorem perfectly, and remember, Pythagorean theorem, the abbreviated version is a squared plus b squared is equal to c squared, remember that. Whenever we can find a group of numbers that makes that true and not have crazy decimals, not have any crazy decimals, but fit that just perfectly, we call those a Pythagorean triple. When we find a group of numbers that fit and work in the Pythagorean theorem perfectly, it's called a Pythagorean triple. Obviously, triple implies that we're talking about 3 of something. All right, so the 3 somethings we're talking about are 3 numbers. Okay? And what I'd like to show you as an example is that if we had a triangle that was 3 units long, 4 units long, and 5 units long, that the Pythagorean theorem would be true, right? Which of the 3 sides would be the hypotenuse? One across from the 90-degree angle, so this would be the hypotenuse. So therefore 3 is a leg, 4 is a leg, and so you can see Pythagorean theorem would be leg squared plus leg squared. And for now, you guys would be asking the question, is that really equal to the hypotenuse squared? And you can see it's going to work. 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is 25, so you can see that's true. So therefore, we call 3, 4, and 5 a Pythagorean triple. Meaning if you create a triangle that is 3 units long, 4 units long, and 5 units long, whatever the units are, inches, centimeters, feet, meters, miles, whatever, the triangle will be right. It'll have a 90-degree angle. And even better, any and I'm going to write out the word here. Any multiple of that is also going to form a 90-degree triangle, a right triangle. So as an example, if we multiply all of these by 2, that's called a multiple. So 3 times 2, 4 times 2, 5 times 2. So if you create a triangle with sides 6, 8, and 10, that would be guaranteed to be a right triangle. Or if we multiplied by 3, 3 times 3, 4 times 3, 5 times 3, we'd be guaranteed to have a right triangle. So all of these individually are called a Pythagorean triple. So once you find a group of 3 numbers that works, any multiple, so if I multiply now by 4, or if I multiply the originals by 5, all of those will be a Pythagorean triple. They'll be the sides of a right triangle. Let me scooch across just to show you one of these. As an example, let's just grab one like this one, and I just want to show you that it makes the Pythagorean theorem true. So if we try 12 squared plus 16 squared, question, does that really equal 20 squared? Let's try. Calculator, 12 squared, 16 squared, 20 squared. 144 plus 256, punch it out, and you get 400, which means we could create a triangle, and if it has a 12-unit leg, a 16-unit leg, and a 20-unit leg, then guaranteed it's going to be a right triangle. All right, so a Pythagorean triple is any group of numbers that makes the Pythagorean theorem true, and then any multiple of those. So what we'll many times do is we'll just start with the smallest group of numbers. So as an example here, we might start with 3, 4, and 5, the smallest group, and then just multiply to get different multiples of that. Okay? As an example, here's another Pythagorean triple. So here's another example of one: 5, 12, and 13. If you create a triangle with a, let's say, 5-inch side, a 12-inch side, and a 13-inch side, guaranteed that it's going to be a right triangle. Guaranteed it's a right triangle. And you can see that with Pythagorean theorem. 5 squared plus 12 squared really does equal 13 squared, because 5 squared is 25, 12 squared is 144, 13 squared is 169, and when you add 25 and 144, you get 169. Okay, so once you find the first one, once you get that first one, here's a triple that works, then any multiple of that also is a Pythagorean triple. So then I could multiply by 2, 5 times 2, 12 times 2, 13 times 2, or I could multiply by 3, 5 times 3, 12 times 3, 13 times 3, or I could multiply by, I'm about to run out of colors here, I could multiply by 4, so 5 times 4, 12 times 4, 13 times 4. All of those are Pythagorean triples, meaning they would be the sides of a right 90-degree triangle. So the initial and then times any multiple, times 2, times 3, times 4, times 5, times 6, times 7, all give us the sides of a right triangle. All give us the sides of a right triangle. Okay? Now, there's several different others, Pythagorean triples, that you could start with. And I'm going to finish this video with one last one and then call it a day. All right? The last one that I'm going to give you is 8, 15, and 17. Those three numbers make the Pythagorean theorem true, meaning they're the sides of a right triangle. Again, I'll just show you that, because 8 squared plus 15 squared really does equal 17 squared. I'll just put it as a question for now. 8 times 8, 15 times 15, and 17 times 17. So when you add 24 and 225, what you get is 289. So you can see that that's obviously true. And once you find one, any multiple also is a Pythagorean triple. So multiply by 2, or multiply by 3, or multiply by 10. All of those then would be the sides of a right triangle. Okay, so I'm going to call it a day there. That finishes off the rest of section 9.1. So you should be all set to go with doing the rest of the assignment. You should have a decent amount of time to do the rest of the assignment. All right, and then I'll see you again tomorrow. Okay, have a good day.